Okay, so for chemical tests, you need to know how to carry out a flame test, which is normally a 2 or 3 mark question. You need to know the results of your flame test, so the colours, and you need to know your test for your anions. Okay, so knowing these definitions should help in understanding this topic. So I would say perhaps give yourself maybe 5 minutes to just look at some of these definitions and write them down. Then you can correct your answers on the next slide. Okay, so these definitions will help. An ion is an atom or group of atoms with a charge, and that's due to an imbalance of electrons and protons. And that means it's either lost or gained electrons, because they're the only ones you can lose or gain. A salt is made up from positive and negative ions. It's formed when the hydrogen is displaced in an acid. So zinc chloride, here the hydrogen in hydrochloric acid has been replaced or displaced by zinc. The hydrogen in nitric acid is displaced by ammonium, the ammonium ion, and then the hydrogen in sulfuric acid has been displaced by copper. Cations, they are positive ions, and here are some examples. An anion is a negative ion, and your salts are made up from a cation and an anion. A precipitate is a solid that is formed when your two solutions are mixed. So precipitate is a solid, has the state symbol solid. Nichrome is an alloy of nickel and chromium, so it's kind of in the name there. And non-luminous is a blue flame. Okay, so this is how to carry out a flame test, and it's a two-step process. You use a clean nichrome wire and you put a sample of your solid over a blue flame. Here, the explanations for the first point is that it needs to be clean so that no substances may affect the colour. Colour is the main thing in this experiment. So anytime you explain why you do something in the flame test, you always use the word colour. And it has to be nichrome because nichrome doesn't colour the flame and it has a high melting point and it is inert. It says, and then 3, another explanation is it needs to be blue so that you can easily see the colour. And again, we've got the word colour in all 3 of these explanations, and hot enough to vaporise the sample as well. Okay, so these are the colours that you need to know. Here's a table. I would advise, perhaps if you're struggling, perhaps if it may help, create flashcards with the colours on the back, colours on one side, and then the formula of the ion or the name of the ion on the other side. So we've looked at how to carry out the flame test, and we've looked at the colours for certain cations in using the flame test. We're now going to look at how to describe some of the negative. The test for the negative ion. Here is a table which shows your test and your positive result for your anions and the 5 anions you need to know in the spec. If you're triple award, you also need to know the ionic equation, and in bold here I've put the formula of the solid or the precipitate which is formed, but also the gas as well in the carbonate that's formed. The ionic equations are really easy once you know what the solid or the precipitate is that you're forming, and then you can work backwards. With your carbonates, they're mostly insoluble, so that's why it's cloudy here, because you have your insoluble carbonate, and in your ionic equation you can see that here that your carbonate is solid and that reacts with your acid to form your carbon dioxide and water. Your carbon dioxide goes up the tube and into the lime water, and there it causes the lime water, reacts with the lime water to form calcium carbonate, which is your solid precipitate, which means it's solid come out of solution. It's generally bad practice to use sulfuric acid in this reaction, because if you use sulfuric acid, you have sulfate ions released from the sulfuric acid, and those sulfate ions can form insoluble precipitates which can form around the carbonate ions to just prevent the reaction from happening or proceeding. With your sulfate ions, you're forming barium sulfate. So you need to add a barium compound in. It's best to add barium nitrate or barium chloride because they're both insoluble. And if you you have to add acid before, and that's to get rid of any carbonate ions just by this reaction up here, or to get rid of any hydroxide ions in which can form also insoluble precipitates. And your barium sulfate formed is a white precipitate just in your barium meal. Now it's the same for the rest of the other three reactions. It's quite nice because your group 7 reactions, they're all the same test, but they just have slightly different results, and the results actually, as you can see, get darker as we go down the groups. That's one way you can remember it: white cream, then yellow. Again, for your these anions, you need to add your acid before to get rid of any carbonates and hydroxides, which may, because if you can remember from the solubility rules, hydroxides are also insoluble, but you want to get rid of any of the carbonates or hydroxides which will form insoluble precipitates and may affect the result. Now you may see a pattern here that for each test you can add nitric acid at the start. So that's one way of remembering. So if you can remember that, you at least get 1 mark going into the exam. I hope this video was useful from the RSC. Your test for halide ions, you first add nitric acid. You can't add hydrochloric acid because remember you'll get a false chloride test. I mean, you can't add sulfate as well because there are some sulfate precipitates which might get in the way, and as you know, that's calcium barium or silver sulfate or lead sulfate, so you can't add those two. So nitric acid is the only one you can add. Then add a few drops of silver nitrate. Your halides are insoluble, so they are solid, and these are your colours. Remember, the colours go darker as you go down the group. In our halide test, we're trying to form silver halides, and these 3 silver halides here. Now this box here just helps us to understand why we have to add our nitric acid first, and that's to remove any carbonate, unwanted carbonate or hydroxide, because both of these ions they can react with our silver to form 2 precipitates, and these can obscure our result. So your silver carbonate can give us a false silver chloride result, and your silver hydroxide formation will prevent us from seeing the color of the precipitate. So adding acid gets rid of both of these ions via these 2 reactions. Our carbonate reacts with the acid, the hydrogen ions in the acid, to form your carbon dioxide and water, and your hydroxide ion reacts with the hydrogen ions in the acid to form water. Now we wouldn't want to add sulfuric acid as well, because sulfuric acid releases sulfate ions in solution, and you can see here that not all sulfates are soluble, so those sulfate ions can react with here particularly your silver to form silver sulfate via this reaction here. So your silver reacts with your sulfate ions to form silver sulfate, which is partially soluble, and that again will affect our results. So nitric acid is the safest here. And again, if you add your chloride, and it's also worth noting that you can't add hydrochloric acid because you release chloride. Hydrochloric acid releases chloride ions, and those chloride ions can react with our silver to form silver chloride. So you'll get a false silver chloride test. So for our test for sulfate ions, we're trying to make barium sulfate. So if you keep that in mind, you know that we're going to have to add a barium compound, and we can go to the start and see what that is. You know that the first step, we always add nitric acid to all of our anion steps. So nitric acid, and if you add nitric acid, then you've got to add barium nitrate. That means you're adding in the same anions here, and that's what we want. We don't want to be adding any new anions which we don't need to add. So we can add hydrochloric acid here, but if you add hydrochloric acid, again you have to add barium chloride, so you're not adding you're not introducing new anions to the solution. The ionic equation for this is your sulfate ions, which we're testing for, will react with your barium to form barium sulfate, and that's your barium meal that we use in medical tracing. Now, barium sulfate is actually poisonous, but the reason why it's safe for us to drink is because it's insoluble, so the body can't actually absorb it, so it just passes through the gut without any harm to the organism. So it's pretty safe because of this property, because it's insoluble. Again, below here we've got a reaction which just helps us understand why we've got to add acid first, because if we don't add acid, and we won't get rid of the carbonate ions, we want to get rid of the carbonate ions via this reaction here, and if we don't get rid of the carbonate ions, then they will react with the barium and they'll form barium carbonate, which is white, and that will affect our results. It doesn't matter about the hydroxide here, because the hydroxide can react with barium to form barium hydroxide, so it doesn't matter here because barium hydroxide is insoluble, and that's probably one of the hardest ones to remember, I always think. So our final test is the test for carbonate ions, and we can add acid. Acids dissociate in aqueous solution to produce hydrogen ions, and they react with your carbonate to form your carbon dioxide and water. In this reaction, you'll observe carbon dioxide gas bubbling through, so you'll observe bubbles and effervescence, which tells us that a gas is produced. We can also test for carbon dioxide test that the gas is carbon dioxide more conclusively by adding it to lime water, and carbon dioxide plus lime water reacts to form calcium carbonate, which is a white precipitate. And if you look at our solubility rules, calcium carbonate is insoluble, and most carbonates are insoluble, as you can see, except for ammonium, potassium, and sodium. And quite interestingly, carbonate is what we actually started off with in the reaction. So you can see here that the state symbol for your carbonate is solid, because most of them are solid, and that's a typical mistake that many students make. They put carbonate ions as AQ, they also sometimes forget to put 2 in front of the H+, and they also indeed forget that water is also produced in this ionic equation. So there's 2 products in this ionic equation. It's also worth noting that you can't use sulfuric acid, because sulfuric acid produces sulfate ions in solution, and that can give us a false result with any of these 4 ions. So this means if you use sulfuric acid, you can't test for barium carbonate, you can't test for calcium carbonate, lead carbonate, or silver carbonate, because you'll get a false positive test. And here's 2 reactions to show the ionic equation with calcium carbonate or barium carbonate. You will get false positive.